Hey, hi everyone. So I went to the thrift store, as one does. I got a little bag of stuff. I'll show you what's in it. And then, so, packet of crayons, glitter crayons. Brand new in box. My daughter will like those. But this is of course what I wanted. This is a Radio Shack calculator with a printer, a little thermal printer. And there's a little tiny bit of paper in there, so we might be able to see if it works. Comes with the case. You gotta like that. Now, because they comes from my thrift store in these bags, you can't tell the state of the battery compartment, and this is heavy, which is not good. So what we've got here is let me get some Radio Shack batteries, which have done a pretty good job on making a mess out of this battery compartment. And so that's going to need to be fixed before we can do anything with any of this. Let me get a small screwdriver. That'll do. I don't want to handle this yuck too much. Well, you can see they've probably all leaked. That one's leaked. So that one's leaked. And that one's leaked. So let's zoom in on this and have a look and see how bad the situation actually is. Let me move the light over a little bit. So there's a lot of blue, but apart from this contact here, which looks pretty bad, the rest have not been eaten into that badly. So let's pull the back off. Let's see what we got. We've got a mess of cables. Does any of these... Oh, is that a plug? Hopefully that's a plug. Yeah, it is. Okay, there we go, we're in. So this was plugged into this on the side. Here's the battery compartment. This is the calculator here, I think, right? Sitting on front, we've got a Mitsubishi chip of some sort. And is that Hitachi? It looks a bit like the Hitachi symbol. We've got a big capacitor here. Transformer, some sort of power supply, and transistors will drive this. So this is the printer mechanism, and that's the power in. So what do we got? We've definitely got some damage on the circuit board here. Now, how much of that is just flux that wasn't taken off when it was soldered is open. I don't see anything that looks like a broken trace. What's the power supply in on this? 4.5 volts. That says 6 volts DC. Is it center positive? Doesn't say. I'm reading this little label, which is about the printer feed mechanism. So So this is going to take a little bit of work to get going. I'm wondering if this whole printer mechanism comes out easily, because if I could lift this whole thing out of here, I could then essentially bathe these. Well, I think I'm going to go get some vinegar, I think, and do a fairly superficial cleaning off. And I'll just clean this board here with some alcohol and see if that gets anywhere. I think that's probably the best approach for the moment. Just let's keep it fairly straightforward. Let's plug it back together, put some batteries in it, and see what's going on. I don't think I see any of the traces being chewed apart. There are lots of test points. It looks like there are test points on just about, if you look over here, we'll zoom in a bit. So my concern would be the traces around here. That says battery minus. So this is probably all the same thing. Let's get a meter out actually and have a look. So really, my concern would mainly be any of this would be, well, I don't drop something off and wreck it, would be this trace here and whether that's good. And it actually looks okay considering, but let's do a continuity check since there are lots of test points and see where that gets us. I've got to say, I didn't get a model number off this calculator. EC 3006. Okay. I don't know if we can see the model number right there. So let's just have a quick look at this and make sure that we don't have anything bigger to deal with, or I have anything bigger to deal with. Okay. All right. So we've got continuity measurement. So that's the battery in. So that should be, there should be continuity there. One of these. Maybe? I don't know. Okay, battery. Yeah, I'm not too concerned with the rest of that. How about from here to here? Yeah, you know, I'm thinking just cleaning it is probably going to do the trick. Anyway, you should be able to see the chip numbers here. Let me zoom in if anyone's interested in looking them up. So HD 43516. And that look like Hitachi? Looks like Hitachi to me. And now, let's see, can I get this one in? M54537P, and then this is probably the date code 812400, 1981. Maybe. I would assume that this is the printer driver because it's attached to here. This is the calculator. This is the printer driver. And then this ribbon cable that goes over to the other side over here, that this ribbon cable is being driven by this. So you kind of have a digital board and then you've got a printer control board over here and a motor, little gearbox, which is, that might be plastic. Anyway, this looks like it moves the head across the paper. There's a tiny little bit of paper. I should measure the size of that so that I know what size to order if I get this working. Well, that's going to be inches, isn't it? 1.5 inches straight on. So that's got to be reasonably standard. I've got to say, I always wanted one of these as a kid, and about, well, 81 would be about right. So I'm pretty happy to get this. I'm thinking, given the kind of construction, that I think 81 might be on. This has the Apple II era feel to it, to me. I just noticed this. This is funny. There's what I'm thinking might be a regulator or something here. And it's got its heatsink turned up to make it fit around these resistors here. So that's pretty interesting. Yeah, I don't know if that's a transformer or or some sort of choke or something. Both would make sense. So here's, let's see, zoom in. Oh, we're zoomed in as much as we are. So it says 5916 DP revised 30P598, and then it says 1P4784. There's another revision. It's not obvious date code to me. Here's a Z40781. That's got to be a QC sticker. So 7th week of 81? No, that wouldn't work, because then that would have been, well, maybe that was manufactured before the chip, but it could be 7th month of 81. And that would actually fit with the chip date here. So I'm going to think that this is from 1981. So I'm going to go back, get some vinegar, get some alcohol, and we'll clean this up as best I can. Then I'm going to put it back together and stick some batteries in it and see if it works. I'm back in a moment. Okay, well, I am back. I'm back, and I've collected what I want. So in this little cup is some white vinegar, and I'm just going to use that to try to neutralize some of the dielectric from the batteries. I want to be very careful not to put too much of this on the circuit board. And we're going to rinse that off almost immediately and dry it off first. What we're trying to do here is just arrest the progress of, sorry, I slid out of view. We're trying to arrest the process of the strong base from the alkaline batteries, damaging anything else along here. All right, so we want to remove the base with an acid and neutralize it. And then we want to get as much of the acid off, because presumably the acid is similarly problematic. I'll start with just a little spray of rubbing alcohol here. I don't think the alcohol itself will do much to help, but the water, small amount of water in it, 30% water, will. Okay, I'll just do one more little squirt with that, and then we'll turn to giving it a good dose of contact cleaner, just to kind of deal with anything else that might be sitting around. But this, as you can see, this is cleaned up pretty nicely. I can't do anything about the damage to the boards. And I can't see the other side of the board without taking this out, and I don't really want to, at least not at this stage. Right, okay. So I got that. Now I'm going to hose down this with a little bit of this is the zero residue contact cleaner. Again, the goal here is just to disperse it enough that it's not going to chew into those traces anymore. We'll acknowledge that it is probably not possible to entirely remove it. Okay, so again, let's zoom in a bit. So looking at the battery compartment here, you can see that this one, those are all going to be fine. This is the one that's of concern. So let's get some fresh. I'll just go all around here and just clean that out a bit. Now the one advantage, the nice thing about this calculator is that with it, well, that label didn't survive. But the nice thing about this calculator is that when it's taken apart like this, it can't really drip into any electronics. So that's good. And you see it gets underneath the contacts because they're formed, right? And it gets underneath. And really the only way to clean them out completely is to desolder them and get them out. Pull them out of the plastic and try to soak them. And I may do that. I've had pretty good luck with just doing this sort of rough and ready approach. They don't seem to get any worse. I've got a Canon flash that I've had for years, and it was just terrible when I caught it. And there wasn't all that much metal left, but I just gave it this kind of approach. And a little scrape with a screwdriver to clean the faces of the contacts like that. And you can do that here too, right? Oh, see, and there's where you have a real problem. Because that one's so bad that it just broke off. And so now we got a problem. And I'm going to be very careful around the rest of them. So that one was much worse than it looked. And we see it got in under the corner there and chewed that right out. And that's the negative side, which is unfortunate. Well, let's toss that in there for a minute. I'll see if I can think of a solution to that problem. Let's just have a look at the other side. Make sure not too much stuff is floating around here. The one thing you can notice is right here, there's a little discoloration along the board. I don't know if that's always been there, because it goes along the whole edge, or if that's associated with this stuff getting on it some way or another. All right, so let's give this a spray out. With the contact cleaner. So I'm going to put this ribbon cable back in place. Maybe I'll give the contacts a little go since we've got the contact cleaner out. Let me zoom back out so you can see what I'm doing. So I'm trying to get this little cable back in here. And there we go. Wipe off the work area again. Okay, so now we can put the screws back in. So for the moment, put that one in there, that one in there. And I'm going to use alkalines in this at the for the first try because I don't know how sensitive it's going to be to voltage. Now, that might work. So let's see. We have power. Okay. Print is on. 110 times 10 equals. It looks like so we may have something more seriously wrong with this. This may just be the voltage dipping. So we've got problems with the keyboard reading. Okay, off. So this is trouble with the keyboard. So it's possible that I've gotten some guck into the keyboard. So we're going to have to take off that we're going to have to take off the bottom board and see where that leaves us. Like I said, it's quite possible that I've got even some liquid in there right now, which could potentially be a problem. I don't think this is the problem because I think this is just carrying data to this board here and power on these two pins here. So that's, I'm sorry, there are at least 9 screws here. I've lost count now. 10 maybe? Well, that is one solution to trying to make a keyboard nice and stiff. Well, let's see. Let's see how bad it is on the other side. All right, there's the LCD. Let's have a look. Not too bad. So let's push this up so you can see as well. So we've got all the keypads here. There's the key matrix with the little conductor stuff on it. There was a little bit of goo in here, so let's, and this is the switch. That we know works. This also goes over to the other board. That's the edge connector. This is the keyboard. Okay, so let's go to continuity. And let's just have, sorry, knock tools onto the floor. Let's just have a look at anything that looks questionable. Okay, so that's okay. That trace is okay. I think that's just a test point on the other end anyway. And that one looks, how about this one here? That's got 2 through holes. It's going to be a couple of these. I'm not sure which ones. This one here. This one here and this one here maybe? Yep. Okay. Yeah, I'm not seeing anything wrong with the board. I mean, that's the scariest one there. But I think it's gonna be all right. So we'll just give this a little hose down and wipe off. And just like we did the other side, essentially. And I'm off camera going to spray this. We'll call this carburetor cleaner for electronics moment. Okay, now one spot we could have a problem is that there's a spring. What does that do? Okay, I know what it does. Here, let me zoom. I don't dare move it. So this spring here, what does that do, right? Well, it comes along and it touches this here. It's grounding the front faceplate to the board here. I don't really know why that was felt to be needed, but it seems like it seems a little excessive, but you know, there were concerns about RF interference in the 80s, and computer design sometimes took some fairly elaborate how do we line up? There's got to be some alignment pins in here. I'm sure I saw them before. There we go. Okay, so there's an alignment pin here, and that goes through the membrane for the keyboard, right? So that pin there, that one there, there's probably more. Sorry for crashing my head into the camera. But what those do is they ensure that the keyboard is aligned. And then we can go in and put our absurd number of screws back in. So I didn't see anything obviously wrong there. Another issue could be something like this big capacitor here in the corner. It could be open. So what we'll do once we get it back together is test the keyboard a bit more carefully. Because I don't see anything obviously wrong with the keyboard as it stands. I'll flip this back over. Well, now we got a problem. That battery wire came off, and that's going to be a bit of a pain to unsolder because of the accumulated muck on it. Let's get the soldering iron. So what I've been trying to do is solder this over to here. And of course nothing will take solder because it's all oxidized. Now to try to deal with that, one of the things I did was put the big tip, well, it looks like a mess, big tip on my soldering iron here. Hopefully that's in focus. And it's up pretty high, but that doesn't seem to be solving the problem. So I'm going to cut this wire rather short. I see some evidence of copper there. Well, to be honest, it looks pretty oxidized to me. I haven't been able to tin the wire. I was able to get a little bit of solder to stick to one spot of this. So I'm a bit hopeful that if I can just get this to tin, I'm going to go all out and give it a good dose of flux first. I'm going to try, see what we can do. So as you can see, the solder won't stick to it at all. So I think the solution is going to be to use a new piece of wire. So that's what we're going to do. Unfortunately, I don't have any. Oh, I do. Just a second. Here we go. I was going to say I don't have any stranded wire, but I do right here. Here, what you would use the positive side of this little thing. This is way too long. Let's cut this down. Trim that a bit. Okay, so let's see if we can tin this wire over here. There we go. No problem. And there we go. No problem. So I am a bit concerned about getting that to go there. Let's give that a spot of flux and see what we can do with it. Sorry, I've got text messages coming in to me. I'll probably have to have a look at those a little bit. If we can get, there we go. Alright. Oh, that's off. Put another little spot of flux on it. It's going to need a little bit more solder than that. That's okay. Oops. Making a bit of a mess here. Yeah, it really is a bit. It's a bit easier to do when I have the board out in some ways. All right. So we got that one together. Well, let's do this one here. Turn this around. And this is not going to be pretty. It's going to be a dry joint. that will do. All right, so we have that repaired. The wire's nice and flexible. We have this one, which goes around here like this. So we can put this cable back in. And down. Leave it in. I'm sorry, I just bashed my head into the tripod again. Okay, I'll leave it in. Got that in. Let's just work on our routing of these wires a little bit. So what I've done is I put it back together. And we'll put that in to make the batteries work again. And we just need to show something down here. I really do wonder if, where did it go? There we go. This is the bit of metal that broke off here. But it is just about the right size, so I've just squeezed it a bit. Let's see. Hey, that works. Okay, now we can close the battery case. Okay, so let me show you what the, I'll shut it off. I'll zoom in a bit, and you can see what the behavior is. So I'll turn it on, right? Okay, and we'll go 5 times, oops, reset, 5 times, reset. Now there's a reset button on the bottom, which I haven't pressed. Let's see what happens when you press that. It resets. Okay. 5 times up. Okay. The display's nice and bright. It's got lots of power. It seems to be working fine. Why isn't it working? Well, shut the printer off. 5 times 5 equals 25 times 5 equals 125. So when it's trying to print, I think the voltage is sagging and it's causing the calculator to shut off. So I think the next step on looking at this thing is going to be to look at the power in the printing mechanism. I'm going to assume that the digital electronics are working okay. So my approach is going to be to check the capacitors on the board, just like I would with a radio. I'm going to check the capacitors that are on the board and see if one of those is an open short. And if one of those is an open short, that would be an explanation for why once the printer's activated, this acts up. But we have the calculator working. That's good. The keyboard works fine. So I'll put this away for now and hopefully come back to it pretty soon. But, you know, it's even got the case, man. We got to make this work. Here we are back a few days later with the Radio Shack calculator. And I'm just going to remind myself of the behavior that we have here, because I want to test and see whether it works, what's going on, and whether my hypothesis about what's going on is correct. So let me zoom in a little bit, and we'll try this again. So if we go like 5 times 5 plus, well, it was 5 plus 5 plus, right? Okay, so we know that it works divided by 5 equals, right? So we know the calculator works fine, all the buttons are working if the printer's off. If we turn the printer on, and we go 5 plus 5 plus. So now actually it's behaving a little bit differently. It's printing. You can see the delay while it tries to print. And there when I hit, you see we get a delay and it's not entirely drying, but the printer isn't working. So what the behavior I had before was that the calculator would essentially crash when it attempted to access the printer. And my hypothesis is that something in the printer was causing the voltage to sag, and that was causing the calculator to crash. It's now, after sitting in a drawer with batteries in it for a few days, not crashing, but the printer's still not working. So what could have happened over those couple of days to change this behavior? Well, as I said, this is a surprise to me. I can think of one thing, and that's that this isn't really a power switch, right? This is just a soft switch, right? So that means that there's power on the circuit, and more importantly, power on the capacitors for a long period of time. And my guess is that what's happened in this period is one of the little power smoothing capacitors on this part of the calculator that is associated with the calculator side as opposed to the printer side has reformed, if that's a thing, and is now keeping the voltage from dropping quite so much that it crashes the calculator. So this is what I'm going to guess at the moment, and it's really just a guess. However, the printer is still not working, and my guess is the capacitors on the printer side haven't had power on them. They probably are only turned on when the printer is used. It kind of makes sense to me. So I think we're still hunting for something bad on the printer board. And I think that the fact that it's working again is kind of sort of supportive of the hypothesis that it's bad capacitors that are the problem. And given this is from 1981, I don't think that's terribly unlikely. So what I decided to do was bring in, let's see how I am for framing here, a power bank. This uses 4.5 volts. The power plug is rated at 6 volts. So I suspect plugging 5 volts in with some alligator clips onto the battery terminals will work fine. And that will allow me to put a meter on. And the only thing I have that does amperage is this clamp meter. So we may have to go a little bit more complicated to get that to work. But, and just to see what happens when you attempt to print. So I'm going to set that up and come back, and we'll see what happens when we try to print. Okay, so hopefully this will be visible to everybody. We've got the clamp meter on here, which is reading 0.03 amps. And we can zero that, it doesn't really matter. We're not interested in the actual amperage, which this is probably not capable of reading accurately at this end of its range. We're just interested in seeing whether we see a big power surge when we try to use the printer. So let's turn it on. We actually saw the power jump up, right? It jumped up briefly and then down, but it's still noticeably higher than when we had it. So let's shut the printer off. No printer. Let's do 5 times 5 equals times, you can go times with these, right? Error. Clear. Okay, so 9 times 9 equals. Right, so we can do it, and we see that in the corner here, that we're sitting at, 8 milliamps, 9 milliamps. That actually doesn't sound that unreasonable to me. We did see a little surge when I turned it on in the first time. Let's see if we can try that again. Okay, so it's off. And you see it's still showing about the same draw, so who knows, right, whether that's reasonable. But we do see that it jumps up and then goes back down. And I wonder if that's what we're watching capacitors charge when we see that, or we're watching, I don't know, something booting. But then we see about the same. And that maybe that's the, I really doubt it's drawing 9 milliamps as its resting amperage. There are ways we could get a more accurate measurement even with this device. I've got this little coil of wire. This is 10 turns of wire, and if you run this in your circuit and then put it through the clamp meter, it slides the scale over here by a digit, but gives you a little bit more precision. Really is what you're trying to do, is get a little bit more precision in the milliamp range. That's nice if you've got a breadboard and want to use one of these little meters, which isn't ideal. I really like the little Unity meter, but one of these days I'll have to get something better. But this is good enough that I haven't felt the need to make the jump to something better until I really get something better, if that makes sense. Okay, so that's enough aside. Let's turn the print on. Okay, turning the printer on caused a jump. So let's see, we'll turn it off. We'll turn the printer on, and we see it went up. Okay, so let's try 9 times. It went up to 1/4 of an amp. 9. Now we'll see equal. And we saw a jump of fairly high pull. Times 9 equals. So we see it going up to, you know, a fairly significant draw, I think, from AA batteries. You know, the highest I saw was like 0.2, 0.25 amps. So I think we can say that there's something. I mean, and obviously the motor could be drawing a lot. So it could be that the capacitors are bad. It could be that the only capacitor that was bad was the one that reformed itself, presumably while sitting with batteries on here. And it could just be that the the motor or something like that is jammed and not working. I didn't hear any sign of a motor trying to turn. So I think I'm going to leave this for the moment, and I want to think about this a little bit before I return to it. I'm going to put the batteries back in hopes that that's good for capacitors and things that magically fix themselves should be left to magically fix themselves for a little longer. So I think that's what I'm going to do for now. And yeah, I think I'll just leave that for now, and then I'll come back after I've had a little bit more time to think about what might be a good approach to trying to test the printing board side of this little calculator. Okay, so this is opened up again. This is off, which is the ribbon cable that connects from here to here. This appears to be the motor drive power, which seems to provide, if you can look over here, goes directly to the back of the motor. There's a capacitor across there. There's a big old capacitor here. The other thing that could potentially draw a lot of power here is the print head, which is under here, because of course it's going to pass current through through the paper to heat it. I think that's how they work. I think it's heated directly by passing the current through the paper itself. I'm guessing that these transistors here control the motor somehow. 1, 2, 3, 4, 5, 6, 7. I mean, it's a lot of, that's something, that's different. I don't know. So I'm trying to think what the best thing to do to test this with. And I've got to say, I'm tempted to put 5 volts across the motor and see what happens. I mean, my guess is that capacitors are bad. I mean, there's this one here, which is all off by its lonesome. And of course, to do any of this, I've got to get this board out and this whole mechanism out. And the other question, of course, is this mechanism jammed? And it's not, right? It's, you can see it's working. So if the motor had power, presumably we would see something going on. What's also interesting is the power comes in there and here. So there's got to be a diode that switches out the batteries, but then where would that be? There's not one on this board here, if I remember correctly. I mean, this board is, you know, this stuff, right, and that. And I don't, you know, this capacitor, it's obviously important. You wouldn't shove a giant capacitor like that in a device like this unless you had to. It's a real packaging problem. And there's just a piece of foam on there. And I mean, it's quite possible it's dried out, right? 1981. It's a long time ago. So I'm thinking that I'm going to try to take this mechanism out. And, you know, my temptation to desolder that capacitor from this board here and test it is pretty high. And then hopefully I've got something that could replace it, at least for the purposes of testing. Then we can order a funny shaped electrolytic capacitor if need be. I don't know what this is over here, this blue thing. It says K on it, and that's all. What does it say on this side? 408H. I've got no idea what that is at all. I mean, I just don't have any idea what it is. It's only got 2 pins connected to it. Yeah, I have no idea what it could be. So I think what I'm going to do is I'll leave that in place, is take this screw out here. So this is really interesting. There are contacts that run around the end of this little barrel here, and they split it up. So what I think it's doing, here's my guess, is that the head must move too as this turns, and that it's doing that to, you know, to mechanically mark where the head is so it can turn on and off the little elements. I was thinking that it would be like a fax machine and there'd be a whole, you know, string of little heaters, but I don't think so. I think it's got a head that's traveling back and forth. I kind of really want to see into it, even if I break it. Okay, that screw is taking this apart. That takes the motor out. Where did the screw go? Okay, so we've now got the motor off. And this goes on here. that. Like that. I can feel the poles of the motor. Okay, does that help us? Not really. And so that rides, this has a little gear in here, right? There's a little tiny straight cut gear, and that rides inside this drum here, which has the switch on the other end and has a little cam here that moves this back and forth. It's very interesting. Okay, so this is clipped underneath. I'm actually going to put this back in because I don't think that screw goes into anything, and I don't want to risk losing parts. So we'll put that back in there and then put this screw Okay, so now, yeah, that's working. Okay, so we got that back together. Not going to touch that. I really want this board out. I don't know. I'm going to try something I shouldn't do. Oh, no, no, no. Look at that. Look at that. It is loose. Okay. So the question then is, what's keeping it down here? Oh, look, there we go. We can see the double-sided tape right here. So really, it's a question of releasing this, and it should come up. There we go. Look at that. Got it out. And that's the mechanism. Okay, so let's put that aside. Let's leave the tape in because I'm probably going to have to replace that to get it to go back together. The tape just goes along the bottom edge and its position is fairly, you know what, we can leave that. There's a little bit along here as well, but that's just foam. So now we've got it apart. So I'm going to assume that this mechanism works and that the problem is here on this little board. So what do we got? We've got this big capacitor, negative on this side. So I'm going to mark the negative side and I'm going to pull off this big capacitor and I'm going to test it. Okay, so what I'm going to do now is find a black pen and I'm going to mark here with a black dot to show the negative side of the big capacitors. The capacitor is 1,000 microfarad at 2.5 volts. 1,000 microfarad. Well, I'm not sure I can make that up out of my assortment of cheap Chinese capacitors, but we'll see. So we'll bring that out, then we'll give that a test and see how we're doing. Let me just put some water in my sponge here. So that I can give this tip a bit of a clean. So we'll just put a little bit of solder on here. Oh, that's not flux from this stuff, that's flux that's been around. Smell the 1980s. I may have to figure out a way to hold that a little bit more tightly. So one thing I do note is that they left very, very long leads on these, I think. Yeah, that's bent over. That went shooting off into the room. But I think that's making it, one of the things that's making it hard to get the solder sucker on here. I'm sort of operating under the assumption that I'm going to have to replace this capacitor. Okay, let's try the other one. Okay, let's see how we are in terms of wiggle power. Not too bad. I'm going to I'll put a little blob of flux on, oh, that's far more than I wanted. And use some solder wick to clean that up a little bit more. The only good thing about all that flux is it'll make this work well. I'm going to bend back. It's cold enough outside that I don't have a window open, so I prefer not to breathe in all of this. This one I think will come out. Bend over this lead a little bit. Now let's see if we can use the wiggle method. There we go. And there we go. So just make sure that my negative mark survived, which it did not. So we'll put another one here on this side and here again. And there we go, because it's not marked on the board. Okay, so there we have our 1000 microfarad capacitor. Warmed up a little bit from the soldering. And let's get, I'm sorry for reaching over, let's get the component tester out and see what we got. I'm going to get that foam off of there. It's totally powder. Let's scrape it off into the garbage with a screwdriver here. I'm sure that was a terrible noise on. So let's see what we can do. I did cut this a bit short. That might work. All right. The capacitor is good. Good. It's entirely on rating. So from 1981 to now, that's still good. Well, let's put it back before we get on to anything else. I know I didn't do a very good job with that. Okay, that's a little better. So that's still on there. Nishikam. So then the question is, the rest of them, whether they're still good or not. The likelihood of any of these disc capacitors being bad seems fairly low. And I don't think any of these traces has been destroyed by the batteries, although we'll have a look at that one. So this one here looks like it's got some damage, but I mean, there's no evidence of any problem. Right there, it's all good. The rest of this, well, there we go. Look at that. I think we found the problem. Let me zoom in a little bit so you can see. So this lead here, you can see there's some damage. This is on the, this is a transistor here. There's the 3 leads. This one comes along to here. So this, that works. So I think we have a break there. I can't really see it. So I think what we're going to do is put a bodge wire in there and see if that solves our problem. Now that we know the big capacitor is, you know, within its rating, that seems, is there anything, well, we're poking around. Okay, so we got that one. Let's have a look. Is this good? Yeah, that's good. Okay, anything else look iffy? We tricked this one. That's fine. That's fine. That's not. Okay. Well, one of the problems here is that that's not. So that's through here. So here to here is bad, but here to here is fine. So we need a bodge from there to there. Okay, that's fine. But that's not. So we'll bodge through there. And that's okay. That's okay. All right, I'll just have a look at this one. Anything else that looks touchy? Okay, that looks all right. So it's this one. It's that one. Okay, so that comes over to here. That's good. That's good. All right, so this side comes over to here. And it comes through. So that's good. So it's only this, the break is here, right? The break's not there. This part is good, so the break is right there. So if we bodged here to here, we'd be good. And this, despite the fact that it looks awful, is good. That's bad. Okay, so I'm going to go get some little bits of wire. There we go. And let's do this. So we're going to go from here. So hold that up there. Let's cut that here. Better find some stickers here. Hopefully this is still recording. Yes, it is. Right. All right. So here's our bodge wire. It's going to go from there to there. And this is where I wish I had put a smaller tip on the soldering iron. Okay, that one's probably good. This is a bit of a mess because the, as we saw before with this wire here, the oxidation from the damaged batteries doesn't help matters. Okay, so let's test. So now here to here, that's good. Now that was this one here, that's good. That looks pretty cold to me. Let's touch that up a little more. Okay, that looks a little better. Well, let's test it one more time. So we're testing from here to this one, I think. Okay, so now we need to bodge from here to here, because this we know is good. So same deal, just a little wire. We'll use a little bit more of this blue stuff because it's conveniently available. I'm going to tin the ends of this again. Not again, for the first time. Come on. I should really get my other packet of solder out, but those little things you get are kind of convenient, at least for me. All right, that's on there, and we need to be and I can see it's already, you can see the insulation's already going. We'll take advantage of that. Trim this down a little bit. Okay, and this is how we're going to do it. Solder it in like this. All right, let's see how that worked. It's not pretty. But it might be working. Okay, so let's get the meter in here, which is shut itself off. I'm getting it all tied up, tangled up in the microphone cable, as I usually do. Okay, so, all right, so we've got here to here. wrong one. We've got here to here, and there to there. It doesn't go to there, doesn't go to there, so we haven't bridged those out. And all right, and these two aren't improperly bridged. No, these two are, because they're supposed to be. Okay, that's ugly, not good at all, but it appears to be working. So, what are we going to do? I think I'm going to reassemble it. I'm going to put this back in here. Like that. With its one screw there. And then maybe see where that takes us. Actually, I'll probably put this in first, like this. So I'm thinking this hopefully works. I'm not going to try to take it apart anymore. That should go in there and comes in under the circuit board, I believe. Yeah, like that. Then this goes in, and we have a little screw here. And hopefully my bodge wires aren't too in the way in the bottom there, but I don't think so. Let's try putting this in. A little bit of gunk there. Let's see. We have power. Did you hear that? Here, let's do it again. I'm excited. Okay, can we get some of this paper in and make it work? I have no idea how the paper actually goes in. Maybe you I don't know, line it up like that and turn it on. Yes. Okay. 5 times 5 equals. Okay, we got to do that again. It's fixed. Okay, here we go. So 10,000 minus 100 equals. It works. It works. We got it fixed. Okay, let's try something else. 64 times 1024 equals. There we go. 64K. There we go. So, I'm calling that a totally successful calculator repair. What was required was cleaning out the battery damage and replacing 2 wires or 2 traces on the little printer board that had been damaged and that I've now bodged. So as we can see, it prints perfectly, nothing wrong with it. And I'm going to order some appropriate paper for this because I've always wanted one of these and this is great. I'm super happy with it. So thanks to everybody who has stuck with me through the repair of this little calculator. 1981, now functioning just fine. And if you like these sorts of videos, you can certainly subscribe to the channel. I try to post this and then a number of sort of random radio things and whatnot around my interests. Although I post sometimes shorter videos a little more often, I generally post longer videos once every week or two. So thanks for watching, and hopefully I will see you again.